Hi, we are building energy modeling intern with UNC Energy Services. So just a brief introduction of ourselves. Hi, I'm Dadria Chen. I'm a junior majoring in environmental science with a quantitative energy system track and also a minor in statistics.
And I'm Jude Severino. I'm a junior and also an environmental science major on the QES track with an urban planning minor. So to start off about UNC Energy, UNC Finance and Operations Energy Services, they pretty much manage a lot of the products of the cogeneration plant, as well as a lot of electricity from Duke Energy and the plant that comes to the campus among all campus buildings, excluding the hospital.
So first, we will start with some of the roles and responsibilities throughout our internship. The first key responsibilities for us was learning about HVAC systems and related terms. This include understanding different system types like VAV, PTAC, and VRF systems, as well as components like chillers, boilers, air handling units, and controls. So developing this technical foundation was very essential for interpreting building designs and identify where energy inefficiency might exist. And the second major responsibility for us was understanding and identify ways to achieve building energy savings. Through the energy modeling, site visits, and discussions with our teams, we learned how to assess the building performance, recognize inefficiencies like poor insulation or outdated lighting, or even the poor occupant behaviors. And we aim to propose targeted upgrades that could lower energy use and operational costs for our campus building.
We also developed energy models using train trace 3D to identify efficiency improvements that could reduce building energy consumption. This was a pretty intense software, a lot of inputs that we used for this. Most of these, as we'll show you, were HVAC, as that accounts for the majority of a building's energy consumption. We also performed campus building site visits to the UNC surplus warehouse, as well as the HVAC system at the Giles Forney building, where we did our internship to kind of assess the specs of a building and what we were working with there.
So in our internship, we used Trace 3D to develop our project. It is a building energy modeling tool that can help us simulate HVAC performance, building loads, and energy use. By creating detailed models of campus buildings, we test upgrade scenarios and estimate their different impact on energy savings and cost. We think that this data-driven approach really allows us to make recommendations for better improvements that can support UNC's sustainability and cost reduction goals. So in our project for the UNC surplus warehouse, we used this software to set up the building model. We first selected a warehouse template to match with the building type, and then we imported the floor plan to map out the layout. Additionally, we also set the local weather and location to Raleigh-Durham for accurate climate data because we all know that the climate and weather is closely tied to the energy use and the user's behavior. And finally, we assign zones like storage areas and offices and restrooms, which really allows us to simulate energy loads for different parts of the building and test the efficiency improvements of the building.
Next, here's like a 3D overview of the surplus warehouse. This is the backside, excluding the front door. This is actually the original building, excluding the addition that came in recent years. We modeled that as a separate building to kind of simulate how those loads would be distributed. As you can see, this is the envelope, and then here are the systems. The first system that I selected were for the two office spaces that are in the building. We chose two changeover bypass variable air volume systems for these office spaces, as these were more suited for small space and very accurately mirrored the actual systems in place there. Next, for the larger warehouse space, we actually split that up into two zones to better model the airflow we used a single zone CV for the left side and another single zone constant volume for the right side. Um, and that you can see that's here. That's more of a system that's engineered for a larger space. Finally, and this is kind of like the whole summation, the final product that Train Trace 3D gives you. On the left, you can see this is the actual analyzed and calculated report section, incorporating a lot of graphics about energy use. You have a lot of things to choose from here. We actually have the project summary pulled up just as a placeholder, but you can use that. And this is actually just a project summary for the load aspect of it. There, as you can see, there's many other types of reports you can get, the energy economics report, entered values, and a comparison between two systems. On the right here, we actually have if you want like more of a overview and a concise summary of these findings that you can get in the actual reports. You can use the alternative 1 versus 2 comparison. Alternative 1 was the actual like first model that we did. This was like the baseline model. For comparison with you can do upwards of hundreds of alternatives. This one was a data center with UFED, the UFED HVAC system. And then we created an alternative two with the same data center with CRAC HVAC system. And you can see down below numbers like the EOI and the peak in kilowatts are projected there. And then the comparison on the next alternative is the change from implementing a different system. As you can see, all these numbers decreased, which is, I mean, that's exactly what you want to see and from a system upgrade. So yeah, some important takeaways from this internship were, as we mentioned, our proficiency in Train Trace 3D Plus, as well as we learned the fundamentals of HVAC components and operation, which is a lot of the internship, mostly just the we learned about that in our first half, and then kind of applied that second, and was a really important part of Train Trace 3D, as we just mentioned as well. And then finally, our familiarity with architectural and engineering drawings. This was kind of an unforeseen challenge that we did not expect to run into. We had a lot of useful help from our mentors, Obi and Anthony. But a lot of these drawings, especially for an older building like the UNC Surplus Warehouse, were more outdated, especially they were on paper, so it's hard to see. And we kind of had a trouble like pinpointing exactly what we were looking for. There's a lot of different arrows going to a lot of different things, but thanks to our mentors, we were able to gain more familiarity with these type of drawings.
Yeah, another important skill I developed was technical energy modeling. So repeated practices using real campus buildings and some online examples, we are able to learn how to build detailed energy models, interpret different simulation results, and be able to connect the data back to the practical building improvements. We also gain valuable experiences in practical decision making because not every upgrade that looks good on the energy report will be feasible on the real world. We learn how to weigh technical benefits against, for example, budget constraints, operational needs, and the long-term sustainability goals to make sure we can make the informed, balanced recommendations for our campus building. And finally, this internship really help us strengthen our professional collaboration and communication skills. Working closely with our mentors and some of the facility staff, it is very important for us to communicate our technical findings clearly and work collaboratively to find solutions that are both effective and realistic for our campus building. And that's all of our presentation. We would like to say a big thank you to our mentors, Obi and Anthony, and our studio instructor, Brian and Liz.